Hi everyone, my name is Thoa and I'm from the University of IEEE. Today I will give a talk about my research. It called an analysis of optimization's performance on chaotic evolutions using multiple chaotic systems with elite strategies. And in my talk, I will divide into five main parts. The first one is the introductions. The second one is the background informations. The third part of my talk is about experimental setting. The next one is about results and discussions, and the final part of my talk is about conclusions. Let me start with the first one, the introduction part. Optimizations is defined as a process to determine the maximize or minimize solutions of a variety of different type of objective functions and different type of domains by finding the best solutions value from a set of the available inputs. And in computer science, the evolutionary computations, which is inspired by the biological evolutions from natural phenomena, can produce highly optimized solutions in a wide range of problem settings. However, most of the evolutionary computation algorithms do not require the optimization buffer to have some specific characteristic or mathematical mechanisms or property to ensure the convergence. They easily come to the top of the environments. So to develop this algorithm, not only physical but also mathematical and biological phenomena are introduced into each framework to obtain new algorithms. And one of the mathematical property can be applied here is the chaotic motions. Due to the ergodic property of the chaotic system, it can help the algorithm to resist any disrupt point in the search space with arbitrary accuracy and movement checking, so-called the chaotic evolutions. And the actual source of the chaotic evolutions mainly depends on the chaotic motions. So if we can change the ergodic property of the chaotic system, we can implement various types of the chaotic evolution algorithms. And in our previous research, we already apply some other type of the chaotic map to the canonical chaotic evolutions, and then discard and evaluate these proposed algorithms. As you can see on the slide, here is some figure of our test function that we use in our previous research. As you can see on the slide, our proposed algorithms, which is the red line on the screen, had a better performance compared to the canonical algorithms, which is the blue line on the screen. However, the chaotic evolutions using TMAP, which is the green line on screen, have a worse performance compared to the others. It caused by the fact that they easily come to the local optimum or the top of the environments. So we can come to some conclusion that the test really emphasize the important role of the chaotic motion to the effectiveness of the algorithms. However, there still exists some remaining problem, and to solve them, we try to enhance the algorithm by using the superior information of the elite individuals in the chaotic search process, and the elite strategies will be a great direction source to our research. Next one, I will give some background information about my research. The first one is the chaotic evolutions. The chaotic evolutions is a population-based algorithm that simulates the ergodic property of the chaos into the evolutionary optimization process. There are three new important concepts which are different from the canonical one. First one is the chaotic vector. Generating is a crucial operation in the algorithms. It is generated by crossing the Tagis vector and the mutant vector, which implement the actual source of the algorithms. The second one is the direction factor, which is controlled by the direction factor race. The last one is the chaotic parameter. It is set initially to a random value and updated in every generation by the chaotic system. It influences the exploration and exploitation function of the algorithms. Next, I will give the main step of the chaotic evolutions. First one, we will generate the initial populations and initialize the direction factor and the chaotic parameter. And then we will choose one individual as the Tagis vector and generate the mutant vector from Tagis vector. Next one, we will crossing the Tagis vector and the mutant vector to create the chaotic vector, and we will compare the finished value of the chaotic vector with the Tagis vector. Which one is the better one will be considered as the offspring of the next generations. And after that, we will update the chaotic parameter from the chaotic system and the direction vector. And finally, we will return and generate other offspring until all individuals are processed using the same operations, and then proceed with the next generations. The About the chaotic system, chaos describes a system that cannot be modeled with the deterministic and stochastic methods, and it has the characteristic of non-linear and unpredictable. Stick map, Tran map, Gaussian map, and Hilbert map. As you can see on the slide, is the equations of this chaotic system, and the parameter setting here is the one will lead the chaotic system come into chaos. And about the elite strategy. Elitism has been known to have a large effect on the searchability of the evolutionary algorithms, and it can effectively increase the selection pressure of the populations and avoid premature phenomena. And in elite strategies, a certain number of suboptimal individuals and the current optimal individual components from the best solutions achieved so far are selected to constitute a elite group at every iteration. And because of the fact that the elite members jointly guide the search directions, elitism could effectively control the diversity of the search process and enhance the exploitation ability of the traditional chaotic search strategies. And elitism had a strong selection pressure so that it can enhance the quality of the search process and increase the effectiveness of the algorithms. And when the mutations operations is carried out, one member is randomly selected from the elite group, and then we will generate the mutation individual from it. After that, we will do crossover and selection operations. Next on, I will give the information about the experimental setting. We will introduce our proposed algorithm that apply the elitism with different kind of chaotic system. Then we will use well-known benchmark functions from CSC chosen and finds as the test functions and apply Wilcoxon sharing test and Freeman test to compare and rank the algorithms. After that, we're going to discuss and evaluate the performance of these proposed algorithms. As you can see on the slide, the parameter setting in our research, we will run the algorithm in 1000 iterations and the number of try run is equal to 30. The direction factor rate and the crossover rate are both set to 0.7. We also evaluate the algorithm in 10 dimension and 30 dimension setting to verify whether they yield different results with a different number of dimension setting. The abbreviations here is the one we use in our evaluation process. The CE here indicate the chaotic evolutions and the ECE here indicate the chaotic evolutions with elitisms. The prefix here indicate the chaotic system we use in our algorithms, and the M here indicates the fusion of this multiple chaotic system. Next one, I will give the result and make the discussion about our research. The mean fitness value of the last generation is shown as a table, as you can see on the slide, and we will apply the Wilcoxon sharing test and Freeman test on the fitness value of the 1000 iterations or the last iterations. The double dark and dark hole here are used when the new algorithms have a significantly better performance than or equal to the canonical one. And look at the results. We can see that the bold one indicates the best results and the italic one indicates the worst one. We can see that the finished value when using chaotic evolutions using elitism in most of the cases are better than the one using conventional chaotic system. Therefore, by the direction of applying elitisms into the chaotic motions have the algorithm to enhance its performance. The chaotic evolution using Tran map obtain the worst results in most of the cases for the test functions. However, in some test functions using chaotic evolutions with elitisms, we can see that the combinations of the chaotic evolutions using elitism with the Tran map has the best performance compared to the others. It's so that the elitism have the chaotic evolution using Tran map to balance its exploitation power, so its effectiveness increase a lot. Our proposed algorithms using fusion of the chaotic system with elitisms has a really good performance compared to the others, which is done by the strong selection pressure of the elitisms to the algorithms. There is a significantly difference between the conventional one using the logistic map with the remaining ones between the worst and the best score for most of the functions. Besides that, look at the conversion curve. Often we can see that it's appears that the conversion curve provided by the chaotic erosion using elitisms look smoother than the one without elitisms. So that the elite strategies have the algorithm to balance its exploitations and exploitation capability. Since we just use the number of time to randomly choose the elite individuals equal to population size over 10. So in the some first iterations, the result of the chaotic evolutions using elitism is not absolute as the one without elitisms. However, by the help of the elitisms, the algorithm using elite strategies escape from the local optimum and get the better results at the end compared to the one without elitisms. It appears that the conversion speed of the chaotic evolution algorithms become down in some benchmark functions, especially for the one using 10 map. However, with the help of the elitism, the chaotic evolutions using elitism do not have this phenomenon to be stable at the end, and the chaotic evolution using 10 map with the elitisms had a significantly greater performance compared to the chaotic evolutions used applying chaotic motions of 10 map. In some cases, for example, the F1, it had a best result at the end. Our proposed algorithm using functions of this chaotic system with elitisms appear to be a promising one. It had a very good conversion speed and finish value compared to the others, including the chaotic evolutions using multiple chaotic system. And with the help of the elitism, we can see that the elitism have the chaotic evolutions to increase its exploitation power and selection pressures, and it affects differently on the chaotic motions of the different type of the chaotic system, so that the elitism have the chaotic evolutions to enhance its performance and escape from the type of the environments. By using the Freeman tag, we also obtain the average ranking of the proposed algorithms. The shorter the column E, the higher the ranking of the algorithm E. So we can observe clearly that the chaotic evolution using elitism give us the better performance averagely. The chaotic evolutions using elitism with 10 map and with multiple chaotic system have the best ranking averagely, while the one using 10 map without elitism had the worst ranking in both of the cases, which show that the elitism significantly affect the chaotic evolutions. Without the superior information from elitisms, the chaotic evolutions applying Gaussian scale motion have the better performance compared to remaining one. However, with the help of the elite individuals, it overcome the chaotic evolutions using the chaotic evolutions using elitism with the fusion of the chaotic system, overcome the chaotic evolutions using Gaussians with elitisms, and had the best ranking. Because the exploitation and exploitation capability that each chaotic map bring to the algorithm is different, so elitism affects differently on the chaotic motions of the distinguishable type of the chaotic system. We come to the conclusion that with the motivation to solve the remaining issue of the chaotic evolutions, we try to enhance it by applying elitism into the well-designed framework of the algorithms. We propose new algorithms that make use of the superior informations of the elite individuals. Elitism has been known to have a large effect on the ability of the evolutionary algorithms, and it has a strong selection pressure, and it also can increase the exploitation power of the search process. We introduce 4 chaotic systems into the chaotic evolution algorithms to make a pair comparisons between the one with and without applying elitisms. We can reach our primary objective to accelerate the conversion speed and enhance the performance of the algorithms. We see that the elite strategy really makes sense in well balancing the exploitations and exploitations power of the chaotic evolutions. We also see that it affects differently on the different type of the chaotic system, which is an interesting topic to further research. In the future, we will try more and more to apply other mathematical mechanisms ability to promote the performance of the chaotic evaluations algorithm. And as you can see on the slide, is the reference of my talk. And thank you for your listening.